Hey guys, welcome back. Today I have a very interesting question here, which is very similar to the tree serialization and deserialization problem that we have already done. But in the earlier problem, what we have done, we used BFS to compress and decompress a string, or you can say serialize and deserialize a string. Right here in this problem, they have actually compressed the string using BFS, breadth first search. Okay. Now we need to decompress the string here. They are using star to denote a null. Okay. They have clearly stated that the compression algorithm included the traversing the tree level by level, which means they have used BFS here, right? So we have to decompress this string using the same algorithm what they have used. So this is how the tree node looks like. It has a left node, right node, data, and a constructor. Okay, we'll use this and we'll form the tree. So there is one more very important thing that I want to emphasize here. The compression technique using a BFS algorithm yields a shorter string than a DFS algorithm. Remember that. Okay. So in the lead code there was a problem to compress the string in the most compact form. So there was one problem we can see. We can go here and we can see this. So this 449 serialize and deserialize BST, there is one thing here. The encoded string should be as compact as possible, right? So yeah, we can use BFS to create a compact string. Okay, DFS will yield little longer string than BFS. Okay, if we would have compressed using DFS for this particular tree 1, 2, 3, then it would be 1, 2 and star, star, 3 and then star, star. Okay, so this is how it would look like if we would have used a DFS algorithm and compress it. But in the BFS algorithm, actually you can see there is no star, star here. So we are saving lot of space while compressing, because in the last level there are no children for 2 and 3, right? I think we can start right now. I think when I write the code it will be more clear to you. So now let's do some sanity check. If str equal to null or str dot is empty, then we will return null. Okay. And in a BFS algorithm, what we do, we usually push the root first. So we will same thing we will do here. We will first read the root. Okay, read the first character from the string and then we will form the root of our tree. How will we read the character from the string when we are doing the BFS operation? This is the most important thing. To simplify that, what will we do, we will actually write a method, okay, where we will pass the index and the string, and it will read that character, read the character in that particular index, and it will create a node for us and it will return us. Okay, the responsibility of this particular method will also increasing the index. Okay, so yeah, so let me write that method for you here. So tree node create node. Okay, we'll pass the string, so str. Okay, we'll pass the index. Okay, yeah, pass the index. Okay, first check if I is in the bound, okay, str length, I is less than str length, then we are fine. We can read the characters from the str, right? So we can say char c equal to str dot char at I. What we can do, if the character is not equal to star, so if you see this null are denoted by asterisk. Okay, so if c not equal to star, then we can create the node, right? So tree node equal to null. Okay, and we can initialize this node with new tree node and we'll pass c, but actually we are reading the characters, so we are going to convert it to number. How can we do that? C minus 0. Okay, fine. And finally in the else case null, but we have already initialized the node equal to null, so finally we will return node here. Okay, so this method actually reads a character from ith index and it will create a node if it can, and it will return that node. Okay, and if it cannot create the node, then it will return null. I will do further modification to this create node. You will see that as I write the code. Okay, so first thing, we are going to create the root, as I said. Okay, so let's first create the root. I'll say tree node root equal to create node str, and we'll pass the 0th index, right? First character will be our root. Because we are using BFS, so we'll use a q and tree node. I'll say q equal to new array dq. Okay, and what we do in a BFS algorithm, the first thing we do is push the root to the queue, right? So if root not equal to null, then we push it to our queue, right? So root, and this is not equal. Okay, and finally anyway we'll return root, right? Okay, now you see, now when we read a character, okay, if you see this second character is a comma, so every time we read a character, we have to make sure that we are skipping the index. Okay, this is one thing, very important thing. Okay, and whenever we are reading a star, also there is a comma after that, so we have to skip that character as well. Okay, so instead of we working on the index, let's give that responsibility to this create node. So instead of I, what will I do? I will pass the index, yes, but let this create node modify the index. Okay, that has to be a pass by a reference, so I will change it to int array of I of one size actually. So what will I do here? I will create a one size array, int I equal to array of size 1, initialize it to -1 first. Now I will pass here I, and here instead of working on I will say I0, and this is very important. Whenever we are reading a character, we are actually increasing the index, right? So when I am going to read the first character from -1, I have to say 0, and then again I have to increase one more index. Before reading we will increase the index, after reading we will increase the index. So what will I do here? I0 plus plus before reading, then read the characters, and then before returning we will say I0 plus plus. Okay, so our create node method is done. Okay, now let's go back to our BFS method again. So we have pushed the root node to our queue. Now exactly same thing we do for BFS, not equal to. So while queue is not empty, is empty, okay, not empty, then what will you do? First thing we do is queue dot poll, so poll, and then tree node equal to this. Okay, now we just have to fill the left child and the right one. So node dot left, what will I do? I will call the create node, okay, and pass the str and I, okay, and create node will take care of increasing the indexes, so we don't have to worry about that. Now if this create node is not null, okay, then we will push it to our queue dot offer node dot left. Exactly similar thing we will do for the right node dot right, create node stri node dot right, and we will push it to the queue if node dot right is not null. Look at the code little bit. Yeah, there is one small thing, str char at, we are passing the array, we have to actually change it to I0. Now let's run it. Cool. So it passed all our test cases. I just wanted to emphasize again, using BFS, if we compress a string, then it will take much less size than compressing in DFS algorithm. Okay, interestingly, we can actually use recursion or also DFS to decompress this particular string. So let's run it. Yeah, fine. Thanks for watching, guys, and this is my channel. I am not going to do thousands of problems in the lit code in my channel, but I would like to target certain questions which are very helpful to open your thought process for cracking a coding interview. You can encourage me by subscribing or liking my videos. Stay tuned and see you next time. Until then, bye, take care.